Assalamualaikum. My name is Muhammad Rafiq Nabil bin Muhammad Lutfi. So I would like to start the presentation about advanced electrical circuit, which is assignment 1, question B and question F. This slide prepared by us. This is our teammate names. Jevintran anak lelaki Radhakrishnan, RAIHANA binti ABDUL HALIM, Muhammad Rafiq Nabil bin Muhammad Lutfi, PRITHIRAMYA anak perempuan KARTHIGASU. Okay. So this is our contents. First, scope of work, introduction of transfer function to board plot to transfer function, discussion, and the last one is conclusion. This is scope of work, which is each have their present about their part. So Jevintran will present about magnitude, pole, and conclusion. RAIHANA will present about details, transfer function. WAFIQ is me, introduction, Facebook plot, and discussion. And the last one, PRITHIRAMYA, will present about board plot to transfer function. This is introduction of transfer function. Alright. The question is, what is transfer function system? Known as a transfer function, explain how the output behave for each and every potential input value. This specific type of function is frequently represented using a block diagram in which the input and output signals are shown by arrows, and the block represented the transfer function. Right. Transfer function is the ratio of Laplace transform of output to the Laplace transform of input when all the initial conditions are assumed to be zero. Okay, it's easily understood illustration of linear time invariant dynamical system is the transfer function. The transfer function is a function of complex variable in mathematics. The transfer function of a system with limited dimension and can be expressed as a rational function of a complex variable, also known as a mathematical function that simulate the output of the system, subsystem, or component. For every potential input is called a transfer function. It is extensively utilized in electrical engineering tools such as a control system and circuit simulator. Okay, so what does the mean transfer function mean to us? The transfer function is a behavior between a single input and single output is described by transfer functions. Multiple transfer functions are used in multi-input and multi-output system to characterize the different input-output interaction. That means the throughput is simply a continuous time system transfer function is defined as follows. Okay, this is the first of introduction of transfer function. So the question is, how are transfer function in electrical circuit performed? As you can see, first, sketch the provided electrical network in the S domain, replacing each capacitance with 1 over SC and each inductance L with SL. You can see the circuit of this. And then from this, use the Laplace transform of each source and time variable to replace VT with VS and IT with IS. The meaning is from VT to VS, from IT to IS. Respectively. So from this to this, so as you can see the difference of the circuit after we using the Laplace transform. All right, we move to the next part. Introduction of transfer function. What is the meaning of board plot? Board graph display the variation in phase and magnitude as a function of frequency and frequency response. Two plots with semi-log scales are used for this. Usually the top plot show the magnitude or gain in dB. So as you can see, you see the first one is a factor, gain and phase. That have a relationship of that. What does the Laplace transfer functions board plot appear like? A magnitude plot and phase plot are included in the board plot for a linear time invariant system with transfer function. S being the complex frequency in the Laplace domain, the graph of the function H in bracket S equal JW or frequency is known as a board magnitude plot.
Assalamualaikum warahmatullahi wabarakatuh. My name is RAIHANA binti ABDUL HALIM. I'm from BELK1333. My matrix number is B0822100066. Okay, today my purpose why I'm here is I'm going to explain about AEC assignment, specifically about transfer function B. Okay, before I go details about my calculation, I will explain about the three combination in transfer function that is important for all of you all to know. So the first one, factor k gain 20 log 10k, the line will be straight in gain and also phase. Okay, the second one is j omega pole at origin and also 0 at origin. Okay, for gain, the line will be increased. It will be at 120 n dB decade. For 1 over j omega simple pole, the line will be decreased. It will be negative 20 n dB. It will be at 1 also. So for this, for the complex one, it will be 1 plus j omega over z. That is, you can plot at z 20 n dB. It will increase. And then the last one, 1 over 1 plus j omega over p. The p value you plot here and it will decrease for negative 20 n dB decade. So I've already explained shortly about the intro. So I will move to my calculation part. So this is the calculation equation given. You have to change it to a standard form. Simplify it basically. Okay. H omega equals j omega plus 10 over open bracket j omega close bracket open bracket j omega plus 5 close bracket square. From the equation above, we know that j omega plus 10 equals simple 0, that is the numerator, and j omega equals pole at origin, that is the denominator, follow as j omega plus 5 square, also denominator, but it is simple pole. So we will get at the end negative 8 equals the gain value. So for the parts of the calculation, I've already stated here. I'll just tell you briefly. Okay, before we want to simplify this equation to a standard form, we have to have three types of element. First, identify the gain k. Second, 0 and pole. 0 is numerator that is already cal, and also pole is the denominator. Third one, identify j omega whether 0 at origin or pole at origin. So denominator equals 1 over j omega. So identify all the elements. We must make the value become 1, so we have to change the denominator. So first, for the j omega plus 10, we have to times 10 over 10. Okay, times 10 over 10. It's already stated here. So it will be j omega over 10 plus 10 over 10 times 10 will be j omega over 10 plus 1. This one. Okay, second one, denominator j omega plus 5 bracket square. Okay, the square is state for decrement magnitude twice. It is negative 40 dB at the pole. Okay. So open bracket j omega plus 5 times 25 or 25 because already 5 square is 25. And then you already expand it, j omega plus 5 over 5 times 25. So the 25 is from 5 to square, right? So the standard form will be j omega over 5 plus 1 square bracket times 25. That is the standard form. This one, yeah. Okay, so for the third one, to find the gain, this is we take out from the equation just now. See j omega over 10 plus 1 and over j omega over 5 plus 1. 5 is square, get 25, right? So the gain is 10 over 25. That is, you simplify, you get 0.4. So lastly, you have to put all the values inside the standard form. So you'll get 0.4 bracket j omega over 10 plus 1 close bracket. This is the numerator over the denominator, open bracket j omega close, open bracket j omega over 5 plus 1 close bracket square. So this is the finalized equation of the transfer function that I have did. And this is the gain we get. So 20 log 0.5, 0.4. So 20 log 0.4 is the gain. You get negative 8. That's all from me. Assalamualaikum and thank you very much.
Hello everyone, my name is Jevintran Radhakrishnan. I'm going to explain about transfer function to block plot. This is my assignment question, question B. Just now my friend explained about this and the answer. This value I going to explain how to plot the graph to magnitude pole. So first, this is the magnitude pole graph that I told. The value of 8, -8 is the gain value for this graph. I plot, so I get the 20 log 10 or 0.4. Next, simple 0 is 10. This is the simple 0 I get. So I just plot to here. This is my simple 0. This is I get 0 and 20 log 1 plus j omega over 10. The next, the pole of origin is 20. This is the yellow one. So I plot 20. I axis to 20 to test the value of the x axis, the 1. So go down. So it touches to and then the value of this graph is 20 log 1 per j omega, and then the simple pole, so that I plot, so 0 to until 5. This is the this is the simple pole will be power of 2. So that's why it tests to the graph value to -40. This is the value of the simple pole, 40 log 1 over 1 plus j omega over 5. This is the blue value of the simple pole. So next I going to explain about resultant. So this the purple line is the graph. This is the resultant value. So first I plot two gain value. This is the between 20 to 0.1, and then the next resultant is the yellow line and the red line between, so it touch to 0.5, so that I plot it, and then we can see next same line that red is that red and yellow, so I plot to 1, so the same of the 8, -8, and then next we can see the three line that white, blue, yellow and red, so it's touched to 5 equal of the x-axis. This is the value that for the resistance value is -20. Finally the uh, simple 0, and we can see simple 0 the gain, simple pole and origin to the same line between. I plot it to get -60. So I plot until down. So this is my result for the magnitude pole. Next, my friend going to explain about Fraser pole.
This is our phase word plot. As you can see, we already done. So, firstly, we must know about phase margin is measured at the frequency where gain equals 0 dB. This is commonly referred to as a crossover frequency. Phase margin is a measure uh, of the distance from the measured phase to the phase shift of negative 180. In other words, how many degrees the phase must be decreased in order to reach negative 180. Next, we must know about gain margin. On the other hand, is measured at the frequency where the phase shift equals negative 180. Gain margin indicates the distance in dB from the measured gain to gain of 0 dB. This value, 0 dB and negative 180 are important because system instability occurs if these two value meets. That means we must know about the top and bottom about the phase plot. Gain and phase margin represent the distance from the point at which instability could occur. The greater the distance of margin, the better, because higher gain and phase margin means greater stability. That means a loop with a gain margin of 0 or even less will only be conditionally stable and could easily become unstable if gain change. A typical goal for phase margin is have at least 45 degrees, and a higher value might be uh, desirable in more critical application. In addition to safety consideration, perform is also affected by values that can be determined. Okay, from both plot. For example, higher 0 dB crossover frequency usually means faster response frequencies, means better noise immunity of lower output ripple. So as you can see, the line, the blue line, which is show the tan -1 W over 10. The red line is a negative 90. The green line is a negative 2 tan the power of negative 1 W over 5. So when you see the orange line, first we see the negative 90 decade, and then we move forward to negative 45 decade, and then we move to a little bit up 45 decade. So that means that's the perfect phase plot that we can investigate after we do all the explanation. So that's all for me.
Hi everyone, my name is Prithi. I'm from 2BELKS1. My metric number is P0822100504. So today I'll be presenting about bode plot to transfer function. As you can see, this is the bode plot given to us. So the first step is we have to determine the K gain. So 20 log equals to K, and to determine the value of K, we need to divide both sides of the equation by 20, where we'll get log K 0 over 20 is equals to 0, and then the logarithmic equation log K equals to 0 can be converted to its exponential form, where we get K equals to 10 power of 0, which gives us the K value which is equals to 1. The next step is we need to determine the slopes and the transfer function. So as you can see, the first part of the bode plot given, we can understand that the magnitude response of the system increases at a rate of 20 dB per decade. This indicates that the gain of the system is amplifying with increasing the frequency. So this positive slope is a clear indication of 0 at the origin. So when it's 0 at the origin, we can write omega is equals to 1 radian per second, because this is where it starts. So hence we can write j omega. The next step is we need to determine the slopes and transfer function of the middle part of the bode plot given. So as you can see this diagram, we can understand that at omega 10 radian per second, the plot levels off, which indicates the effect of the 0 is counteracted by a pole. This means there is a simple pole present at omega 10 radian per second. A simple pole decreases the slope of the bode plot by negative 20 dB per decade. Since the initial slope was positive 20 dB per decade, due to the zero, the presence of this pole results in a flat response which is 0 dB per decade after omega 10 radian per second, which is why we get here a flat. This indicates the gain remains constant across this frequency range. So from 10 radian per second to 50 radian per second, the gain is constant at 20 dB, indicating a simple pole at omega 10 radian per second, which neutralizes the effect of zero. So now that we have found this is a simple pole with slope omega equals to 10 radian per second, we can write as 1 over j omega 10 plus 1. The next step is we'll determine the slopes and transfer function for the last part of this bode plot diagram. So as you can see, we can understand at omega 500 radian per second, the plot shows a decrease with the slope of negative 20 dB. This indicates another simple pole. The gain starts to decrease with increasing frequency, showing the characteristic behavior of a single pole, which causes a negative 20 dB per decade slope. So now we know that this is a simple pole with slope at omega equals to 50 radian per second. We can write as 1 over j omega over 50 plus 1. So now we're at the final part, which is combining all the elements into one transfer function and simplifying it. As you can see, I wrote h omega equals to j omega over 10 plus 1 and j omega over 50 plus 1. The j omega here is the zero at origins equation, and then this is the first simple poles equation, and this is the second simple poles equation. Now why I times 10 over 10 here and 50 over 50 here is because I want to get j omega over 10 and j omega over 50. So solving mathematically, I times 10 over 10 and 50 over 50. So I get j omega plus 10, and here I am left with 1 over 10, and here I am left with 1 over 50. So when I times this, I get 500 j omega over j omega plus 10 and j omega plus 50. So this is my final answer. The general equation, the general transfer function, h omega equals to 500 j omega over j omega plus 10 and j omega plus 50. That's all for now. Thank you.
So now, I would like to discussion of transfer function. So a mathematical description of the relationship between a linear time invariant system input and output is called a transfer function. Is frequently employed to explain how electrical circuit behave. Next, Laplace transform are commonly used to express a circuit transfer function, a mathematical technique for analyze dynamic system in the time domain is the Laplace transform. An individual can determine the transfer function of a system by performing the Laplace transform on its input and output signal. So a circuit transfer function explains how the circuit react to various input signal frequency. In the frequency domain, it is basically the ratio of the input signal to the output signal. Okay. Next, the transfer function which connects the input and output voltage may be obtained by performing the Laplace transform on the input and capacitor voltage, which is may be obtained by performing the voltage. Okay. Next, for instance, the impedance of the resistor and capacitor may be used to determine the transfer function and the straightforward RC resistor capacitor circuit. Okay, for the last is a transfer function are critical for understanding how electrical circuit will react under various input signal and condition scenarios, which make them indispensable for circuit analysis and design. There we widely employ the signal processing, control system, and other branches of electrical system. Next, for the last one is a discussion of board plot. System analysis. Board plot help engineers and analyze the stability, bandwidth, and overall performance of a system. They can identify resonance frequencies, gain margin, and phase margin, which are crucial for ensuring the system operate of desire without instability or excessive distortion. Okay, next, design and optimization. Engineers use workflow to design and optimize filter, amplifier, control system, and other circuit. By examining the workflow, they can adjust component values or system parameter to achieve the desired frequency response and performance characteristics. Okay, next, frequency compensation. In control system design, workflows are used for frequency compensation. Engineers can shape the magnitude and phase response of feedback system to improve stability. Alright, so work plot shows the frequency response, change in phase and magnitude as a function of frequency of a linear time invariant system. So, which is it aids in the analysis of the control system stability. Plot, which is a poles and zero, should be located on the left half of the S-plane and for the smallest phase transfer function. Alright, that's all from me. Thank you.
From the conclusion for this assignment, we know that a board plot also provides a representation of frequency response of system and that the transfer function represent the connection between the input and output signals. They are made up of magnitude and phase poles which offer information on the phase shift and system gain at various frequencies. Both plots are helpful for examining the properties of the frequency domain, resonance, and system stability. They also serve as an assessment of faculties, stability, education, and analysis. In summary, both plots are powerful tools for analyzing and designing systems in electrical engineering and control theory. They provide valuable insight into the frequency response of a system, helping engineers make informed decisions during the design and optimization process. So that's all for our presentation. Thank you.